We are going to do exercise 1.1 from the book. This is the first exercise of chapter 1. We need to find the graphical solution of this LP problem. In order to do that, we need to graph the constraints and find the feasible region and then the optimal solution. So we're going to graph the three lines 2x1 plus x2 equals 70, x1 plus x2 equals 40, and x1 plus 3x2 equals 90. So for the first one, when x1 is 0, x2 is 70, and when x2 is 0, x1 would be 35. So we have the straight line from 70 down to 35. And this is the line 2x1 plus x2 equals 70. It's important to remember which one is which. So now for the second one, when x1 is 0, x2 is 40, and when x2 is 0, x1 is also 40. So we'll have the straight line from 40 to 40, and this is x1 plus x2 equals 40. And now the last one, when x1 is 0, x2 is 30, and when x2 is 0, x1 is 90. So we have the straight line from 30 down to 90, and this is x1 plus 3x2 equals 90. Now the feasible region is the area of the graph that it is less than or equal to all of these three lines, but also we want x1 and x2 to be greater than or equal to 0, which means that our feasible region is this area. So this is the feasible region. Now, the next step is to draw some level sets. So we're going to choose z to be equal to 0, to be equal to 1,200, 1,600, and then z to be equal to 2,000. We need to also remember that z is 40x1 plus 40x2. So now we need to find what x1 and x2 are. When z is 1,200, both x1 and x2 are 30. So we're going to have the line from 30 to 30, and this is going to be our first level set. This is when z equals 1,200. Now for the next one, when z is 1,600, both x1 and x2 are equal to 40. So our next level set will be from 40 down to 40, which is this line. And here we have z is 1,600. Now for the next one, when z is equal to 2,000, then both x1 and x2 are equal to 50. So our next level set will be from 50 to 50. And this is when z is equal to 2,000. And we are going to draw z equals 0 last, because it is the straight line that goes through 0, but also it needs to be parallel to the other level sets. So it will be this line. And this is when z is equal to 0. Now we chose these level sets because we need to get values of x1 and x2 that match our axis, basically that are no less than 10. Here we chose these values for level sets only so that we can get values for x1 and x2 that match our axis. Now, to find the corner point that gives us the optimal solution, we need to look at the last level set that is part of the feasible region and the level set that just left the feasible region. Say, for example, if this area was part of our feasible region, then we would look at the level set z equals to 1600 and the level set of z equals 2000. And then our optimal solution would be at this corner here, because this is the only corner that exists between these two level sets, the one that goes through the feasible region and the one that just leaves the feasible region. But in our case, the last level set that goes through the feasible region is when z is equal to 1600. And at that point, at this line, we have two possible corner points, which are this one and this one. And they both give the optimal solution, which is z equals 1600, which is a special case. This is not what happens usually. So in this case, we have two corner points that give the optimal solution. So we say that we have a non-unique optimal solution. The optimal value is equal to z 1600. Now we can also find the coordinates of the 2 points. So for this point, we can see that it is the intersection of the lines x1 plus 3x2 equals 90 and the line x1 plus x2 equals 40. So in this case, we have to solve this system in order to find the coordinates of the point. We are going to subtract the second equation from the first one, and we have 2x2 is equal to 50, which gives us that x2 is equal to 25. And if we put that back into the second equation, we get that x1 is equal to 40 minus 25, which is equal to 15. So the first corner point is 1525. Now for the second point, we can see that it is at the intersection of the lines 2x1 plus x2 equals 70 and the line x1 plus x2 equals 40. So we're going to do the same with these two lines in order to find the coordinates of the second point. We have x1 is equal to 30, and if we put that back into the second equation, we get that x2 is equal to 10. So the second corner point is 30, 10. So to summarize, we have a non-unique optimal solution that we can get from the two different points of the feasible region, 15, 25 and 30, 10, and the optimal value is 1600.